All right, today we're going to build something super useful, a simple little web server that lets you check a room's temperature and humidity right from any device on your Wi-Fi. We're using the ESP32 because, well, it's cheap and has Wi-Fi built right in, which makes it absolutely perfect for these kinds of projects. So let's dive right in. And just to give you a sneak peek, this is what we're aiming for. A clean, simple web page showing that live data, updating every few seconds. Yep. By the time we're done, you'll have this exact page running on your own network.
So, what is this thing we're actually building? Well, you can think of it as your own personal, super local weather station. It's a tiny device that just sits in a room and reports the climate directly to you, all over your own network. Pretty cool, right?
Okay, so to make this a reality, we obviously need a few pieces of hardware. But don't worry, the shopping list is super short. These are just the basic building blocks we need to get going.
You know, the hardware for this is actually pretty simple. It really just comes down to two main parts. First, you've got the ESP32 microcontroller. That's the brains of the whole operation. And second, the DHT11 sensor. This gives our project its senses, letting it read temperature and humidity. It's a fantastic little sensor to start with. Though, fair warning, it's more for general room readings, not, high-precision science. The breadboard and wires, they're just the skeleton holding it all together.
All right, we've got our parts. Now it's time to connect everything. And I know wiring can sound a little intimidating, but trust me, for this project, it is unbelievably simple. We just need to make 3 little connections.
Seriously, it all boils down to just 3 little wires. That's it. The first one connects VCC to the 5-volt pin, that's for power. The second connects the 2 ground pins, or GND. And the last, most important wire, connects the data pin on the sensor to a GPO pin on the ESP32. We're using pin 26. That GPO, by the way, stands for General Purpose Input-Output. It's basically the channel that lets the brain listen to the sensor. Okay, hardware's all connected. Now for the fun part, bringing this thing to life. And to do that, we need to give it some instructions, which we'll handle with some code in the Arduino IDE. Now, before we jump into the code itself, we got to talk about a key concept here, libraries. Think of them like pre-built toolkits for your code. Instead of having to write tons of lines to connect to Wi-Fi or figure out how to talk to a sensor, we just include a library that already knows how. It saves you a ton of time.
And here's the best part. The code we're using is pretty much ready to go right out of the box. You don't have to write it yourself. You just need to pop in 3 little pieces of information to make it work for your specific setup.
So these are the only 3 things you have to change in the code. First, your Wi-Fi network's name. That's the SSID. Then your Wi-Fi password. And finally, you just have to tell the code which GPIO pin you connected that sensor's data line to. For us, that's pin 26. Simple as that.
All right, the hardware is wired up, the code is customized, we are on the home stretch. Now it's time to upload the code and finally see our live data dashboard in action.
So this is the big moment, right? Everything is set up and ready to go. But how do we actually find the web page that our little device is now hosting on the network?
Getting that address is super easy. First, you upload the code to the ESP32. As soon as that's done, you open a little tool in the Arduino IDE called the serial monitor. The ESP32 will then connect to your Wi-Fi and print its IP address right there for you. That address, that's its unique location on your home network.
So what do you do with it? Just grab any device on the same Wi-Fi network. Your phone, your computer, whatever. Open up a web browser and pop that IP address right into the address bar. Hit enter and boom. Okay, so this works perfectly, but there is one little catch. As the source material points out, the only problem is that this IP address might change. Your router could assign a new one the next time you power it on, which, let's be honest, is kind of annoying. But thankfully, our code has a much smarter solution built right in. It's called MDNS. The easiest way to think about MDNS is like a little phone book just for your local network. It lets all your devices find each other using a simple name instead of a number that can change.
And that is the real magic of that library we talked about. So instead of hunting down that IP address every time, you can just type esp32.local into your browser. It's stable, it's easy to remember, and it just works. No more copying and pasting numbers. And that's really it. You're done. With just a couple of components, a few wires, and a tiny bit of code, you've actually built a fully functional, web-connected data server. That is genuinely powerful.
You know, the biggest takeaway here is that this is just the starting point. We used a temperature and humidity sensor, but this exact same framework opens up a whole world of possibilities. So I'll leave you with a question to chew on. Now that you know how to do this, what else could you monitor?